This next section is about using your tangent line to approximate values of a function near that point of tangency. The reason we might want to do this is that lines are super easy and curves are a little bit harder to calculate. I'm going to start with a story. Once upon a time, there was a mathematician. And there was a function, a messy function. And the mathematician thought, gee, that's messy. I wish that were a line. Lines are nice and easy. I love lines. So he got out his glasses and he picked an easy point and he looked at it closely. And closer still. He kept looking until it wasn't so messy and it looked like a line. He loved lines. He even had a tattoo that said lines. So the moral of the story is any differentiable function looks like its tangent line if you pick a point and look closely enough at it. Linearization is the process of using the tangent line equation to estimate values of the function that are close to the point of tangency. So we're going to do an example. We're going to use linearization to estimate the square root of 51. So the way we do this is we say, I would need a calculator to figure out the square root of 51. But there's a value on the square root function I don't need a calculator for, and it's close to 51. And that value, so my function here is the square root function. And the value that's easy to evaluate on that square root function is 49. 49 is really close to 51. And if I could figure out the tangent line equation at 49, I can use it to estimate the square root of 51. Because notice, like, here's 49, like right here. 51, like the tangent line and the square root function are basically at the same place at that point. They're really close together. So square root of 49 is 7. And the slope of the square root function at 49 would be 1/2 x to the negative 1/2. So I put 49 in there. So it would be 1 over 2 times root 49. So 1/14. So my tangent line equation is y equals 1/14 x minus 49 plus 7. So that's this blue tangent line. And now if I want to estimate the square root of 51, I'm not going to plug 51 into the square root function because I'd need a calculator, but I can plug 51 into this linear equation, which is really close to the square root function. And I would have 51 minus 49, which is 2. So that would be 1/7 plus 7. So the square root of 51 is approximately 7 1/7. The other thing I know by looking at this picture is that my estimate of 7 1/7 is a little bit too high. And I know it's a little bit too high because notice how this tangent line is a little bit above the curve. So it's too high because the tangent line is on top of the function. Now, if you live your life in modern times, you always have a square root button in your pocket because you always have a phone in your pocket. But my grandpa was the kind of guy who came of age when a 4-function calculator cost $100, and he ran out and bought one because he was excited to have one. But that 4-function calculator did not have a square root button, so he wouldn't have been able to figure out the square root of 49 on that calculator, but he could have easily figured out 7 1/7 on that calculator. So 7 1/7 on a calculator is 7.14 143, let's say. And then if I take the square root of 49 on my calculator,
on my calculator.
It's not working. I should have done this before I started. I know the square root of 49. Yes, I could have done that without a calculator. My goodness, the square root of 51 is what we're doing. Square root of 51 is 7.141. So my estimate of 7 1/7 is a little bit bigger than the actual value, and we could tell you that from the picture. All right. Use linearization to estimate cosine of 1.5.
Rascal came on his shoulder.
So for this problem, the tricky part is I need a value that's close to 1.5 for which it's easy to figure out the cosine. And so if I think of pi over 2, that's about 1.5. It's close to 1.5 because pi is close to 3, and 3 divided by 2 is 1.5. So I'm going to write the tangent line equation at pi over 2. Remember, to write a tangent line equation, we need three things. We need an x-coordinate, pi over 2. We need a y-coordinate, and that would be 0. And we need a slope. So our function is cosine. Our derivative is negative sine. And negative sine of pi over 2 is negative 1. So our tangent line equation would be y equals negative 1 x minus pi over 2 plus 0. And then if we plug 1.5 into that, we get negative 1 times 1.5 minus pi over 2, and we get a value. Of about negative 0.071. All right, so given that our function is natural log of x plus 1, use linearization to estimate the value of 0.1. So this time, I need an x-coordinate that's close to 0.1, so I'm going to try using x equals 0. So if I'm writing a tangent line equation, I need three things. I need an x-coordinate, I need a y-coordinate, natural log of 1 is 0, and I need a slope. So that'd be 1 over x plus 1 times the derivative of x plus 1, which is 1. So f prime of 0 is 1. So my tangent line equation is y is equal to 1 times x minus 0 plus 0. So the value of 0.1 is approximately 0.1. And if you want to check that on your calculator, you could grab a calculator and say, well, what is natural log of 1.1? How does that compare to 0.1? And when I do it, I get error. Never mind. I get, on my calculator, 0.095. So that's about 0.1. Oh, there's a picture. Sorry about that. And you can also see from the picture that when we grabbed a calculator, we got 0.095, which is a little bit smaller, than when we used a tangent line. And the reason for that is you can see that the tangent line for this function is on top of the curve. So that's why that value is bigger. So that's why our estimate is too high. All right, last one. We have a function that is the square root of x squared plus 9. We're going to use linearization to estimate the value of negative 3.9. So let's try our x coordinate close to negative 3.9. Let's try x equals negative 4. So then our y coordinate would be square root of 16 plus 9, which is 25, which is 5. And then our slope would be 1/2 times x squared plus 9 to the negative 1/2 times 2x. And so f prime of negative 4 would be 1/2 times the square root of 25 times 2 times negative 4. And so stuff cancels and we get negative 4/5. So our equation for our tangent line is y equals negative 4/5 x plus 4 plus 5. And then if I use negative 3.9, I have y is equal to negative 0.8 times 0.1 plus 5. So negative 0.08 plus 5. Good, thank you. So our estimate is 4.92. And if I look at this graph, it looks like as I'm close to negative 4, yeah, I'm really close to 5 there, right? And we can also say that's an underestimate of the actual value of negative 3.9 on the function. We know it's an underestimate because the tangent line is lying below the curve at that point. That's linearization. That's using the tangent line equation, which we know how to write, just to estimate the value of the function.